Hi guys, sorry I'm not in class today. Please turn to page 26 in your packet and look for Day 5 coordinate proofs. Today we're going to use distance, midpoint, and slope to prove properties of quadrilaterals. To do that, we need to review the distance formula, the midpoint formula, and the slope formula. I'm going to show you an example of the distance formula and the midpoint formula before we get started. If I want to find the distance between 2 points, I can use the distance formula. And I'm going to do the point 0, 1, and 6, negative 2. It doesn't matter which one you make your x1 and your x2. If I write the distance formula, x2 minus x1 squared plus y2 minus y1 squared, and I plug in all of my information, I'll have 6 minus 0 squared, and I'll have negative 2 minus 1 squared. That'll give us 6 squared plus negative 3 squared, which is 36, plus 9, which is the square root of 45. Really, the distance formula is just the Pythagorean theorem repositioned to solve for the hypotenuse. If I want to do the midpoint, we normally use SAD, but I wanted to show you the midpoint formula, how that looks. We use x1 plus x2 over 2, y1 plus y2 over 2. And when I plug in my values, 0 plus 6 divided by 2, 1 plus negative 2 divided by 2, I get 6 divided by 2, negative 1 divided by 2, or 3, negative 1 half as my midpoint. That's the same thing as stacking them, adding them, and dividing by 2. So when we look at our notes, it's just recapping that on page 26. And if you look at the bottom of page 26, it's reminding you about the slope of a line. We use the slope of a line because we want to prove if the opposite sides are parallel or not. If you turn to page 27, it's asking you to determine the coordinates of the intersection of diagonals FG, HJ with those vertices. So the first thing I'm going to do is I'm actually going to graph this. Looks like a parallelogram. I'm going to graph it, negative 2, 4, that's F, 3, 1, 2, 3, 4, 5 is G, 2, negative 3 is H, and negative 3, negative 4 is J. And so in order to figure out the coordinates of the intersection, we have to think about the fact that the diagonals cut each other at the middle, or in 2 equal parts, or bisected. The diagonals bisect. So what we're going to do is we're going to use the midpoint. And we can find the midpoint of FH, or we can find the midpoint of GJ. F is negative 2, 4, so x1, x2. H is 2, negative 3. I'm sorry, that should be a y2. And a y1. Miss Lucas cannot get herself together. And an x2 and a y2. So now we use the midpoint formula. Negative 2 plus 2, 4 plus negative 3, we'll get 0 over 2, 1 over 2, which is 0, 1/2. And I wonder if that looks kind of accurate. So if we come look, it looks like it's about 0, 1/2. So that's good. So that's how we find out the coordinates of the intersection of the diagonals. If you turn the page to page 28, what they're going to do is they're going to use the distance formula to determine if the diagonals bisect each other. Now remember, when they bisect each other, we want, for example, JP to be the same length as PL. So I'm going to find the length of JP, I'm going to find the length of PL using the distance formula. I also am going to look at the other diagonal, because that's going to be interesting to me whether or not the diagonals are congruent. They're asking that in part B. So I'm going to do KP and I'm going to do PM. So I'm going to use the distance formula 4 times. And in order to do that, I'm going to have to figure out my coordinate pairs. So K is at the point 2, 5. J is -1, 2, 3, 4, 5, -5, 1, 2, 3, 4, 5. And then M is at -8, -1. L is at -1, -1. So I'm going to find, and P, of course, I'm going to need -3, -2. I just read those off the graph. So what I'm going to do is I'm going to find this length, this length, this length, and this length. And if they're the same on each diagonal that you have, then I know they bisect each other. So JP, really doesn't matter which one x1, x2 is. 2 minus -5. Sorry, I made a mistake there, folks. Let me back up. I was doing the length of the side. I want to start here and do -3. My apologies. -3 minus -5. That's better. And -2 minus 5. And so when I simplify this, I'm going to get the square root of 13. Because this will be 2 squared. And this will be 3 squared. -2 minus 5. That's a positive 2. That's why I'm having trouble. Positive 2. So that'll be a -3. Square root of 13 is correct. When I do PL, from P to L, I'll have -1 minus -3 plus this -1 minus 2. That'll be 2 squared, -3 squared, and again it will be the square root of 13. So we can see that this diagonal is being bisected. If I do KP, K to P, -3 minus 2 squared plus 2 minus 5 this will be -5 squared, and this will be -3 squared, which will give me 25, 9 square root of 34. So I can already tell that the diagonals are not congruent. And that's important because it tells us whether or not this is a rectangle. If the diagonals are congruent, we know there's a very good possibility we have a rectangle. And we do Pn, -8 minus -3 plus -1 minus 2. And that will again be -5 squared plus -3 squared, which is again the square root of 34. So all we know in part A is that the diagonals do bisect each other because there are two equal parts for each diagonal. But as for part B, do the diagonals show themselves to be congruent? They do not, because this two pieces added together will give me 2 square roots of 13. These two pieces added together will give me 2 square roots of 34, and they are not congruent. Now, as far as slopes go, part C, this is the important part. We haven't done anything with slope yet. Wants to know if the consecutive sides are perpendicular. Remember, perpendicular slopes have negative reciprocal slopes. I'm going to write that here. Negative reciprocal. I'm going to abbreviate that. So we have to look at two consecutive sides. And it really doesn't matter which ones we pick. I went ahead and calculated the slope for all four. So I did the slope for JK. Remember, it's y2 minus y1. Let me write that up here. y2 minus y1, x2 minus x1 for slope. So the slope for JK, 5 minus 5 over 2 minus -5, which is 0 over something, 7, which is 0. Now the only way that these would be perpendicular is if this were straight up and down. And I think you can see that this is not a vertical line. It has a slope, something different. So let's look at the slope for KL, and I think that'll be enough for us to conclude that they're not perpendicular. So I would do -1 minus 5 and -1 minus 2. And again, this slope would have to be undefined with 0 in the denominator. And it's not. Its slope is 2. So they are not negative reciprocals. So they are not perpendicular. And if you look down at the bottom of your page 28, what you see are some interesting ways to prove that something is a parallelogram. And you do not need all of these. You only need one. You only need one condition to be true. So you show that both pairs of opposite sides are parallel. You do that using the slopes, because parallel lines have the same slopes. Show that both pairs of opposite sides are congruent. You do that with the distance formula. You calculate the distance between the 2 points for all 4 sides. Here you're looking at opposite angles. On the coordinate grid, we don't usually do that very often. It's just one of those things, we don't have a good way of measuring that without a protractor. We can show that the diagonals bisect each other with the midpoint formula, and we can show that one pair of opposite sides is both parallel and congruent. We can do that with the slope, showing that the slopes are congruent, and congruent with the distance formula. So if you take a look, go ahead and turn it over to page 29. What it's asking you to do here is it's asking you to graph the quadrilateral and determine whether the quadrilateral is a parallelogram. So this is a yes or a no question. And they're asking you to justify your answer using the slope formula. So think about it. If they're asking for slope, we want to know if opposite sides are parallel. And we're going to calculate the slope for all 4 sides. So I'm going to graph the quadrilateral. 1, 2, 3, 4, 5, 6. I'm going to have to go out one. And you can do the slope with the rise over the run, or you can do the slope with the formula, whichever you prefer. Either one will work. So this was M, and this was N, and they certainly do look parallel, but again, that's not enough. We actually need to evaluate the slopes and see. Sorry, my picture's not that beautiful. So if I look at KL versus MN, using the slope formula, I would have 4 minus 3 over 8 minus 2, which would be 1/6. And if I look at the opposite side, that slope for NM would be -3 minus -2 over 1 minus 7, which is -1 over -6, which is 1/6. So those are parallel. But now I have to test the other two sides. But it is possible for a quadrilateral to only have one pair of parallel sides, and that would be then a trapezoid. So I'm going to try NK. So -3 minus 3 and 1 minus 2, 6. And I'm going to try ML, do that slope. And so I'll go 4 minus -2, 8 minus 7, and I'll get 6 over 1 equals 6. And they are also parallel, because they're the same. So is it a parallelogram? Yes, it is. Okay, so that's how you use slope. Now when you shift down to the bottom and you use distance, that is where we're looking at opposite sides being equal. And I think that part is just basically using the distance formula. You know you have to use it 3 times. You have to calculate all 4 side lengths. That's A, B, C is 1, 2, 3, 4, 5, 6. Right there. And D is 1, 0. Okay. So if you look at the distance for AB, okay, so A is 3, 3, B is 8, 2. We're going to have 8 minus 3 and 2 minus 3, and that's going to be 5 squared plus -1 squared, square root of 26. Let me shove this over just a little bit for you there. Then we're going to do DC because that's the opposite side. So C is 6, -1, and D is 1, 0. So we'll do 6 minus 1 squared, -1 minus 0 squared. And so then you'll have the 5 squared and the -1 squared, and you'll have square root of 26. So those opposite sides are good, but we have to check them both. So now we're going to do AD, and we'll do 1 minus 3 squared, 0 minus 3 squared. So we'll have -2 squared plus -3 squared is 4 plus 9, square root of 13. I'm happy. And then BC, let's see if it's going to be the same thing. 6 minus 8 squared, -1 minus 2 squared. Well, here's our -2 squared. Here's our -3 squared. And again, we get square root of 13. So this is great. So we can determine that this is, yes, a parallelogram because both pairs of opposite sides are congruent to each other. If you turn the page to 30, we're going to show you another one at the top where you would do the midpoint formula, or you would do SAD. I'm going to leave that to you guys. I think you guys can handle that. What you'd be looking to do is look at the midpoint is showing the same midpoint. Okay, so we can talk more about that next week. What I want to get to briefly is looking down at the bottom of this page before I sign off. I think I've made this long enough as it is. We can go even a little further. We can say, okay, determine that it's a parallelogram the same way we just did by checking out the opposite sides. See how they got the square root of 52, square root of 52, square root of 13, square root of 13. We can say, okay, great. Opposite sides are congruent and it's a parallelogram. But can we tell if it's a rectangle? And so what we're going to do here is we're going to do the distance formula 2 more times. And we're going to be doing the diagonals. Because remember, in a rectangle, the diagonals are congruent. And so what they've done here is they've calculated the length of the 2 diagonals, and they're the same length. So we can conclude that this is a rectangle. We just have to do a little bit more work. So if you flip over to page 31, they're showing you another example where they want you to determine if it's a rhombus, a rectangle, or a square. And the part that is the most important on this page right here is the plan. It says it appears from the graph here that the parallelogram has 4 congruent sides. Now I went ahead and proved that, and I got each one of the sides was the square root of 85. And so I won't go through and do all that for you because I think I'm going to bore you more than I already have. But I figured out that that was true. I just pulled the coordinates off and did the distance formula 4 times. It says it appears that the figure is a rhombus, but not a square or a rectangle. It says if the diagonals of the parallelogram are congruent, then it's a rectangle. We learned that on the previous page. If they are perpendicular, which means their slopes are negative reciprocals, then it's a rhombus. If they are both congruent and perpendicular, then the parallelogram is a rectangle, a rhombus, and a square. So what I did on this one was I checked out the diagonal length. Whoops, lost the pencil there. And for diagonal KM, I got the square root of 68. But for diagonal JL, I got something totally different. And honestly, this looks more like a kite to me, but it's not. It's just the way it looks on the graph. But this is solely a rhombus. Okay, and I think we could prove that the diagonals are perpendicular if we look at their slopes. So let's take a look at JL, at the slope. 2 minus negative 2 over 9 minus negative 7. So that is 4 over 16. So now I'm going to check the slope of KM. Negative 4 minus 4, 2 minus 0 is 8 over 2, negative 8, sorry, which is negative 4 over 1. And these are negative reciprocals. Can you see the 1 over 4 and the negative 4 over 1? So our diagonals are perpendicular, and we know we have a rhombus for sure. But what this proved over here was that they are not congruent diagonals, so it is not a rectangle or a square. So what you do is you'll flip over to your homework. Your homework is on page 32. It says homework. You have 4 problems there. And on page 33, see you next week.